Hi everyone. So my name is Guillaume. I'm a PhD student at EPFL and I like compilers. I'm going to talk about compilers and how we integrate them with IDEs. So first off, like, what's Dotty? So Dotty is this cool new experimental compiler for Scala, which has a completely redesigned type system internals inspired by Dot, which is this formal calculus we use to make sure our type system makes sense. But externally, Dotty is very similar to Scala 2. We have a website, check it out. So one interesting thing about Dotty is that since we more or less start from the ground up, we can redesign a bunch of components. For example, we get better incremental compilation where we avoid forgetting to compile some stuff, and better pattern matching exhaustiveness checks. One interesting thing is that we wrote a paper on that, and the design was adopted for Swift. So tooling, this is a tooling conference, right? And people want good tools, otherwise they're not going to use your stuff. And Scala already has pretty good tools, so if we want people to use Dotty, we need to be as good or better than the existing tools. So we have a REPL, which even has syntax highlighting, thanks to Lee Howie. And we have Dotty.doc, which we use to generate all of the documentation of Dotty itself. But what I'm going to talk about today is IDEs you brought. So what exists so far in the world of Scala? So we have two kinds of IDEs based on the Scala presentation compiler. That means the Scala compiler itself in a mode used to get information for IDEs. There's Scala IDE, the Eclipse plugin, and there's Enzyme. And there's another re-implementation of the Scala type checker, which is the Scala plugin for IDE. And of course, I'm not going to say anything bad about these projects because the people working in these projects are in this room. One thing I can say is there are quite a lot of lines of code, except Enzyme, which is short and slime and nice. Enzyme is the most interesting one of those, actually, for our purpose, because it has this server-client design where you don't need you're not tied to a specific IDE. But it's still not something that we can directly reuse for Dotty. Like, it solves a lot of problems which are different than the kind of problems we have in Dotty. But there's lots of ideas that we can reuse probably, and maybe at some point we can see some sort of convergence between Dotty IDE and Enzyme. Anyway, so say we have a not invented here syndrome, and we want to reinvent everything, so what are our design principles? One is code reuse. As much as possible, the IDE should not have its own custom ways of doing things. It should be like regular compilation of Scala code. Otherwise, you get bugs which only happen in the IDE, and that's very frustrating and very hard to fix. And the other important principle is you don't want to be tied to a specific editor, because while some editor might be like in fashion at some point, fashion changes, right? And of course, it has to be easy to use and to install. Like, you shouldn't have to read a very long manual to figure out how to use the thing. So let's go step by step through these principles. So the first one is code reuse. And I'm going to talk about how you talk with the compiler, which is what you want to do from the IDE. You don't want to reinvent things, you want to ask the compiler stuff. So the compiler is this huge pipeline of phases. You start with your source code, you run it through the parser, you get an untyped tree. Then you run it through the typer, you get a type tree, and then all the phases after that, they simplify the trees until you get to something that can be emitted as Java bytecode or JavaScript or something else. And the one we're particularly interested in for querying the compiler is typer. And to explain that, I'm going to go with an example. So say you have this very simple source code. You have some final val, lm equals 1, and another val which references lm. And I have put some little emoji to show where your cursor is in your IDE. And you want to do jump to definition, so you want to go to the definition of lm. So if I look at the type tree I get after type checking from the compiler, and I print it, it looks like this. So I have all the information I need, and every tree node at this point has a type and a position. So based on that, I can figure out where is the position of lm, and I can jump to it. But now if we go a little further in the compiler pipeline, say after first transform, Now I have a problem. If I look at my definition of foo compared to previously, like we've lost information because of constant folding. So at this point, I don't know how to jump to LM anymore because I don't have a tree reference to LM in the type tree. This is why we need to be able to query the compiler as early as possible in the pipeline. So the way we do that is when you open a file in your IDE, we're going to type check it and then stop the compiler, not do the rest of the compiler pipeline. You get a tree, you store this tree, and then when the user does something like ask for a definition, you look in this tree. So a bunch of queries in the IDEs are just answered by traversing trees. So this raises a question like what to do about code which has already been compiled. So usually in your IDE, you have a few files open, but you probably have big projects with hundreds of files which are not open. So what you can hope for is that these files have been compiled before, which means you have class files for them. And class files in Scala are a bit special. They have pickling information. So we have this phase, which is still very early in the compiler pipeline, which stores information which is used in subsequent compilation. So in Scala 2, we use this to store method signatures, which means that if I try to compile a file, and then I try to compile another file which depends on the first file, I cannot just use the method signature from the Java bytecode because they lose information. In Java bytecode, we don't know about generics, for example. So this is stored separately, but still in the class file. In Dotty, we have something similar to Scala 2, but it goes much further in that we store the full type tree. So why would you do that? This is what we call tasty, because pickles are tasty. It's a typed abstract syntax tree serialization format. And the main motivation is to solve the binary compat problem, which is that if you have dependencies which use JVM bytecode, then when you change something in how the compiler emits bytecode, you might break your binary compatibility. And you cannot either rely on doing everything from sources, first because it's slow to recompile everything from sources, and because the compiler might have changes which are not source compatible but are binary compatible, say if the type checking algorithm changes. So Tasty is sort of this intermediate solution where instead of relying on either the bytecode or the source code, you rely on the typed abstract syntax tree. So we haven't fully realized this in the sense that we don't have a build tool which takes advantage of this. But we can use Tasty for other things. And one of these things is to provide interactive features in IDEs, because you can just deserialize the typed abstract syntax tree of your class files and then query them. And this is really interesting because it means that you use the exact same code to query trees open in your IDEs and trees which are in your class files. So there's less code duplication and less bugs. So to do this, we designed a very simple set of interactive APIs which are not specific to any usage to do tree traversals, compiler lifecycle management. We use them in the IDE and the REPL. So when you ask for completions in the REPL or the IDE, we use the same code. And in the future, we probably want to do more stuff like interruption handling or being able to only type check something, what changed in the IDE and not the full file. But it's fast enough for now. And all of this is just less than 1,000 lines of code because all of the hard stuff is part of the compiler itself, which means it's much easier to maintain. Okay, so second design principles, editor agnosticity. So this comes to the IDE portability problem, which is if you have M IDEs and N programming languages, you usually need N times M IDE plugins. And that's annoying. It's hard because it means that IDE plugin authors need to be experts in IDEs and experts in compilers. And because there's lots of IDEs and lots of programming languages, there's lots of duplication. So the language server protocol, which has already been mentioned in at least one talk today, is one attempt at solving this. In a way, it's similar to what Enzyme does in the sense that you have a server, which is your compiler, and you have a client, which is some IDE, and they communicate through a protocol. So the way the LSP works is it comes from VS Code, but there's been a bunch of alternative implementations now. It uses JSON RPC. the IDE tells the language server when the user does something, say ask, I want to go to the definition of the symbol at this point. And the language server is responsible for maintaining an internal state of what the user has open, that kind of things. And the language server will notify the IDEs when it has type check code, it has found errors or warnings. And the IDEs can also send requests that are usually triggered by user actions. And it's completely asynchronous and cancelable, meaning that your IDE should never freeze because the compiler is busy trying to type check something. So implementing the Dotty language server was very easy because all the low-level stuff is done using the LSP4j library. And now we have Scala libraries to do LSP stuff that didn't exist when we started doing this. But we can't really use Scala libraries in the Scala compiler itself because of bootstrapping issues. So we use Java libraries, and LSP4j is pretty good. And all of the implementations relies on the interactive APIs from the first part of the talk, which means that all in all it's like 500 lines of code to do a language server. I don't think I'm going to go into details, but this is how we query for definitions. And it just involves getting position of something, finding the tree with this position, finding the symbol for this tree, and then traversing trees to find where this symbol is defined. And the last design principle is it has to be easy to use. So right now, we basically have a Dotty IDE plugin, which is only for SVT and which takes care of generating all the stuff and even launching VS Code for you, which means you only have to type one command and bam, you have an IDE working. And you don't need to install an external plugin because the IDE plugin is part of the SVT Dotty plugin that you need anyway to write any kind of Dotty code. But we can do better. We can do 0 commands. And I think that will be possible once we have the build server protocol implemented in Dotty and in the SVT. So there will be a talk tomorrow about the build server protocol, so you can defer to that. So I'm going to skip all that because it's not super interesting, and then can go back to our design principles. So code reuse, we have our compiler APIs for interactive usage, which can be used for a bunch of things and which are very small. Editor agnosticity, we just implement the LSP, and easy to use, one command. But hey, I hope we can do better. And I still have a bunch of time, so bonus is debugger support, which is something that looks like it'd be very hard, but thankfully there's something called the Java debug server, which was implemented by Microsoft. It's only for Visual Studio Code because Visual Studio Code is the only implementation of the debug protocol for now. I hope other IDEs start implementing it. And because Scala compiles to Java bytecode, making a Dotty debug server was very easy on top of that. Most of the stuff just works. I'll show you a demo later on. One challenge is expression evaluation. So expression evaluation. So imagine you're in your debugger in some class which has 2 methods, foo and bar, and you decide to put a breakpoint inside bar, and then you want to evaluate the expression foo. And now things get complicated because to be able to evaluate foo, you have to somehow execute code on a remote virtual machine. So there's 2 JVM in play here. There's the one which is actually running your program, and then there's the one that drives the debug server that communicates to the other JVM through the Java debug interface. And I cannot just send foo to it because it's not even a type check expression. And type checking Scala code is not trivial. So what I need to do first is somehow insert my expression I want to evaluate in the source code, because I do have the source code. and then run the whole compiler pipeline. And if I do that, it turns out that foo becomes this.foo of y because of implicit resolution. So now I'm a bit further along, but I still don't know what to do with this expression, this.foo of y. How do I send it to my remote virtual machine? So I could compile this to bytecode, but then what do I do with this bytecode? So the first thing I'm going to do is extract it to a static method, this expression. So you will notice that this has become $this, and all the parameters that were used have become parameters of a function. Because basically all of this stuff, $this and y, are local variables that are in my stack frame when I'm in my debugger, but they're not accessible outside of the debugger. So they become parameters of my function. So I still cannot send that to my remote VM because my remote VM does not know what $this and y are. So I need to do something a bit lower level and define a static exec method that take just a self, which is the self that I can get from my debugger, and the list of local variables that I can also get from the debugging APIs of the JVM. And then out of this, I can then compile global, and now somehow I have to send this code, which is compiled and which is a static method, to the remote VM. So how do I do that? Turns out we can just cheat, and on the debug VM, we can assume that in the standard library, we put a magic thing to load something which comes from the class path, which takes some self variables and some local variables, and just execute that stuff. And then from the debugging VM, I can use the fact that the Java debugging interface APIs allow me to send a call to a method on the remote VM. So I'm going to get the class path for my compiled global class, get the self and local variables from the debugging interface APIs, and then somehow do a remote call. And when we use the JDI APIs, it looks like this terrible thing, and I have skipped most of the stuff, but basically it's a very hard to use API, and you don't want to use it if you can avoid it. So the way I avoid using it is, instead of, say, for every call in my expression, I try to translate it into a JDI API call, which is what, for example, the Scala IDE does, and I think IntelliJ too. I just generate a bytecode for my whole expression, and then just have one remote call where I run this bytecode. And we can try it out. So this is code that only runs on my machine right now because I haven't merged it or finished it, but it's good enough for a demo. So I'm in the VS Code in the Dotty IDE. We can see that things like type on hover works. I've put a breakpoint in some method. I'm going to run the debugger. And it stopped at my breakpoint. And already I have a bunch of stuff that I get for free just thanks to the Java debug server doing a bunch of work for me. So you can see all the local variables, and you can even like pick inside them and see inside my tree I have a field called const, whatever. I have my core stack, and I go up or down in my core stack. And even cooler thing is I can hover over some value, and I can see the content of the value from the debugger point of view for this variable. Okay, but now let's try to evaluate some code. Let's start with something easy. Okay, so 6 times by 7 is an integer because of boxing, whose value is 42. Good. But that's not super impressive, right? But I can show you that type checking is actually working because I can do implicitly of context. And I get back a context object. How you want to, does that help? All right. So that's not super useful by itself, but already we can see, so we have this tree thing. So I can do like tree.toString, and I see that I have this string here. But then I can pretty print it using the show method, and show takes an implicit context parameter. I can just skip that and use implicit resolution, and I get the pretty printed version. Yeah. All right. So future work, optimizations. So as I said, we could do better to avoid using the, like, when you type check something in the IDE, right now we type check the whole file every time you press one key on your keyboard. We could do a better job and just say we type check the current method and not everything after that. I think the Scala IDE already does something a bit like that. More features. A big one missing is documentation and hover. And we can do that, I think, if we just add documentation to tasty. And then that enables a bunch of things, because we could get documentation in the REPL very easily. We could do like :doc some class and get the documentation for this class. And we could get incremental documentation generation. Better build to integration. So see the talk on the BSP protocol tomorrow. To finish off, I think nowadays it's important to design compilers with interactive use cases in mind, because this is how people want to use them, and because it makes the design of a compiler better. And you should also design your build tool with interactive users in mind. And this is what the build server protocol is attempting to do. And we can go beyond what current IDE and REPLs offer. And I think like a very good food for thought is what IDEs does, and there's this book like Type-Driven Development with IDEs, which goes into details into what they do. And I think we can get a lot of inspirations from that. All right, I think I'm done, unless people want to do more demo stuff.
Okay, so thank you for the talk. I have a question, because you mentioned that the editor should send a message that the user changed something in a file. But what happens if you change a file outside the editor, for example, by checking out a branch in your version 1 control system?
Yeah, that's a very good question. So the issue is, what happens if the source file is more recent than the binary file, the class file, because the user changed it outside of the IDE, so the IDE doesn't know it changed. So the way we deal with that in Dotty, and I think in Scala IDE too, is whenever we load a symbol, we check if the source file for the symbol is more recent than the binary file. In that case, we don't trust the class file, and we type check from the source. I think we can do better than that if we have build tool integration, because, for example, when you change a file and then you change it back and you type compile in SBT, SBT is smart enough to know that it doesn't need to recompile anything, because it keeps the checksum of the file to know if it changed or not. So if we can ask the build tool through the build server protocol, hey, is this source file more recent than the binary file, then we could get even better precision for that kind of things.
Okay, my question is about macro support. Do you design for it? For example, if I will take example of play JSON formats.
Mm-hmm.
So I can click on my formats.reads and jump there. I mean, is that basically is it designed for a support of macros already, or will you patch later on?
So Dotty doesn't have macros for now, but once it gets macros, supporting them in the IDEs will be like we won't have to do anything special because we just reuse the regular compiler to compile stuff. And there's nothing special about macros from the perspective of the IDE. So it will just work, hopefully. And then we can imagine things like being able to ask the IDE to ask the compiler to expand the macro at some point so you can see what this macro generates. That kind of things shouldn't be too complicated to do.
More questions? No, I guess. Okay. Okay,
One
I
question.
think... there's a question.
So can Dotty parse or understand Scala code? What's the interoperability story?
We can compile all of the Scala standard library, and we can compile various projects. But so we have a community build. If you go to github.com/community build, but it's very small for now because we've been doing it ourselves, and we only have a few projects that we've taken the time to try to get to compile with Dotty. So most projects, you do have to change a few things to get them to compile with Dotty. But a lot of these changes can be automated with Scala fix, hopefully. And yeah, we have a compatibility mode for Scala 2 code. So if you compile with -language:\Scala2, your Dotty code, we use Scala 2 rules for some things like type inference of some stuff.
Okay, thank you very much. I think most of us here are thankful that you have in mind our productivity and making sure that the new compiler works well with every tool we can imagine. So I would like to thank you for this wonderful talk and give a round of applause for Guillaume.